And just like velocity is a measurement of how quickly the position is changing, the acceleration is a measure of how quickly the velocity is changing. So it measures how quickly the velocity is changing. And the definition of the acceleration as a function of time is the time derivative of the velocity function which you can also think of as d dt of the velocity function. And that means that it's the second time derivative of the position function. Or you can write it this way. The units for acceleration are length over time squared. And that means that the SI units are meters per second squared. And let me go back here for a sec. Okay, so there's a few things to keep in mind about acceleration. So notice so the first one is on the position versus time graph, the acceleration is the concavity of the graph. So if the P versus T graph is linear at a chosen instant, then the acceleration is equal to 0 there. That's an inflection point if you have a graph that's curving. If the P versus T graph is concave up, at the chosen instant, then A is positive. So that's if you're talking about something like that. It looks like the mouth of a person with a positive mental outlook. And if the P versus T graph is concave down, at the chosen instant, then the acceleration is negative at that instant. Okay, so now what does acceleration tell you physically? When we talked about velocity, we talked about if the velocity is positive, it means the object at that instant is moving in the positive direction. If it's negative, the object's moving in the negative direction. What does it tell you if you have positive or negative acceleration? Well, in motion along a line, or for motion along a line, changing the velocity, all it can do is change the speed of the object. The object can't move off the line, so it's not like it can turn right or something, you know what I mean? So non-zero acceleration always means the speed is changing. We'll see when we get to two-dimensional and three-dimensional motion that that's not true necessarily, because since objects can change their direction, the velocity can change even if the speed is staying the same. But for now, a non-zero acceleration means the speed's changing. So what do you think it would take for the acceleration to tell you that the object's speeding up? Maybe the first thing that would pop into your head is like positive acceleration. Yep.
The acceleration and the velocity have to be of the same sign.
Yep, that's exactly right. So if the velocity and acceleration have the same sign, the object is speeding up. Which direction is it speeding up? Well, you can get that from the sign of the velocity. So if they're both negative, since the velocity is negative, it means the object's moving in the negative direction and speeding up. Okay? If they're both positive, it means it's moving in the positive direction and speeding up. If the velocity and acceleration have opposite signs, it means the object is slowing down. And again, you can tell what direction it's going from the velocity. What's it doing if the velocity is 0 and the acceleration is, say, negative? Yeah, once you're at 0 velocity, you can't go any slower. So it's definitely speeding up, and it's starting to move in whatever direction the sign of the acceleration is. So that means that it would be starting to move in the negative direction, but it hasn't built up any velocity yet. These derivative relationships for velocity and acceleration, where is that? So that also tells you there's an integral relationship. If you know the acceleration, you can integrate with respect to time to get the velocity. You have to, in that case, deal with constants of integration, and I'll talk about how. Okay. So let's say that we have a position versus time graph. So let's say that the position versus time graph is this. Let's say it starts here, does that. Okay. And let's say that that represents a motion let's say of an object moving along like a ramp. And let's say the zero position is here and the positive direction is this way. Okay, so first, over what intervals is the object moving in the positive direction? Sorry, I'm going to draw this a little more. So I'm just going to break this up into, I'll make an inflection point there and here, and let's call these points. So that's 0. Let's call this A, B, C, and D. So over what intervals is it moving in the positive direction? Well, yeah, actually, I mean, it's not perfect, but yeah, I'm sort of thinking of this as the only place that it's horizontal is at time equals 0 on this side. So the slope is positive all the way from 0 to B. Okay, so it's moving in the positive direction from 0 to B. So now let's draw an arrow in the direction of the motion. That interval from 0 to B. So now we're switching from this totally mathematical thing to putting an arrow in the real world that represents this motion. Which way is it going? It's going in the direction that we chose to be positive, which is left and up. Yep. Question? Okay. Any questions about that? The connection between the sign in math world and the direction the thing's moving? So and now over what intervals so I'm going to not write down the like questions about when's it moving in the negative direction, but that's just going to be the from B to D and on. So when it's during that interval from B to D, it's moving in the negative direction. What's an arrow in the direction of that motion? Yeah, it's going to be just opposite the positive direction. Okay, so now over what intervals is the acceleration? Let's do negative on this one. Yeah, so we're looking for places where it's concave down. And so it's going to be from the inflection point at A to the inflection point at C. Okay. Everywhere else it's concave up. And now one more question. When is the object speeding up? Well, there's kind of two intuitive ways to think about this. One is to think about, is it going from closer to zero slope to farther from zero slope? Because that would be speeding up. Or is it getting closer to zero slope? That would be slowing down. Or you can just, over all these different intervals, think about the sign of the velocity and the acceleration. And when they're the same, it's speeding up. When they're opposite, it's slowing down. So from 0 to A, the slope is positive, right? Velocity is positive, concave up. They're both positive, so it's speeding up from 0 to A. Okay. And B to C, that's right. Those are the two places where it's speeding up. From A to B, it's slowing down because the slope is positive, but it's concave down. So you have a positive and a negative. Then it's speeding up here because it's a negative slope and a negative and concave down. Okay. And then slowing down again and getting back to zero velocity, slowing down, starting with a high speed and getting to zero speed. So the two intervals are 0 to A and B to C.